Assalamualaikum warahmatullahi wabarakatuh. We would like to present our project term from Computer Network Design, COE-546. Our project title is VRF-Aware Fast Reroute Under Failure. Our team names is Netwalker, Muhammad Hamdani, Abdul Rahman, Rabiu Ibrahim Kabir, and also Abdul Samad Ali. Okay, we would like to explain about the aim of our project is to evaluate how four VRF-aware network designs maintain service continuity under link failure and recovery condition by comparing the jitter, packet loss, and throughput. This is all the metrics that we measure. The objective is we measure the throughput, jitter, packet loss under the normal conditions, and then we simulate the failure conditions where uh, we shut down one of the interface between the two routers or two the switches. And also we measured how quickly traffic stabilized after rerouting or link restorations. The tools that we use is iPerf3 and MTR. Okay, we go to the first design, the design P0. This design is actually between the three of the routers or the layer 3 switches is using the OSPF as the underlay uh, protocol, routing protocol. And the OSPF is function for the IP reachability. And inside the configuration, we also have the VRF routing. So by the VRF, we can have uh, virtual routing forwarding means we can have different routings uh, even though we are using the same physical address, same physical device. And in this case, we have two VRF ID, VRF blue, and also VRF red. And we can sure that between the VRF red and also VRF blue is not conflicting, and we can we can go uh, service connectivity from the Linux 1 to the Linux 2, which has same VRF ID. This is our labs, which is deployed on the emulator of ifng, and as according to the design P0, uh, it's configured with OSPF, and there are two VRF in NX1. Let's see. I would like to show about the VRF status. Okay, the VRF there are two VRF ID, blue and red. It's currently up, and also we can show that the interface status between the VRF. Show in IP interface brief of VRF all. Okay, as you may see, there are two VRF ID, and each VRF has different interface, so it will not be conflicted. Okay, I will show you how the communication is not conflicting. Let's say we are from the VPC2. I would like to ping two other VRF blue. Ping 1 and 2, 168.20.10. It's reply, right? Because it's same VRF. But how if go to different VRF, ping 1 and 2, 168.30.10. It's time out. So VRF isolation is finished, and we will go to the measurement. Okay, in order to measure by using the iPerf, so we have to start the iPerf service. iPerf 3 main S. This is on the server side, and from the client side, we do the iPerf 3 minus C 1 and 2 168 40.10. This is the target, and using the UDP, and the bandwidth is 10 megabits. The interval is 0.1. Okay, let's see the result. Okay, as you may see, the result is like this. This is the bitrate, and also uh, we can start the the measurement. As you may see, okay, the result has available now. We can see the bitrate and also the jitter between the two links. And on the other hand, we also measure during the failure. So during the measurement, we incidentally try to shut down this interface. Okay, now we have prepared our configuration. From the NX2, we will try to shut down during the measurement. We change the interval to be 0.1. Okay, and we will shut down the interface. Okay, now the result has ready. So there's a jitter and also there's a packet loss. This is we measure how many packet loss during the failure, and also we measure during the recovery. We try to measure again and no shut the interface. Okay, it's ready. So during the recovery, there is no packet loss. This is for the design P0. And actually, we also deploy another design, which is design P1. This is more scalability. Instead of just design P0, where in design P0 we have to deploy all the VRF configuration, all VRF ID on all the routers or the switches inside the network. But in this case, we are using the OSPF as the underlay and also the MPLS as the transport layer. We also use the MPBGP VPN as the exchange of the VRF communications. And for the design P2, it's similar with the design P1, but the difference is they are using the segment routing MPLS. This is the other features of the MPLS, which is using the segment ID instead of the label LDP. And in this design also we have the features TILFA, where the TILFA can uh, calculating the all the alternate paths before the failures happen. So if there is a failures, it can has faster convergence time. And the last one is the FVX-LAN. The FVX-LAN is uh, we can spend our layer 2 networks in geographical uh, area distance. I mean, so even though we are separated different distance, we can have a virtual switching like this one from the R1 and R2, even though it's different locations, but they have can one subnet ID. And the network is use the OSPF as underlay and BGP VPN, and the the latter layers is the VXLAN. And as the result, our conclusion is the performance comparison shows that each network designs can maintain the connectivity, but the segment routing MPLS with the TI-LFA provides the most stable performance during the failures and recovery, with lower packet loss, lower jitter, and faster traffic restoration compared to the other design, because they have the capability to calculate the alternative paths before the failures happen. And thank you very much for watching. Assalamualaikum warahmatullahi wabarakatuh.